I want to talk about fitting data to polynomials, and I'm going to begin the discussion by talking about a polynomial that we know very well, and that's the linear polynomial, the equation of a straight line. And the equation of a straight line, we know, can be written in the form of y equal to a sub 1 times x plus a0. You might be used to seeing it written like y equals mx plus b, but I have a particular reason for, instead of writing m, for wanting to write a1, and instead of writing b, for wanting to write a0. So if we have 2 points, how can we find the line that goes through those 2 points? I've shown on this coordinate axis here, here's a straight line in red, and here are the 2 points that the straight line intersects. It's the point x1, y1, and the point x2, y2. Now what this means here is that the x-coordinate of this point is x1 as shown here, and the y-coordinate of this point is y1 over here. Similarly, for this point, we have the x-coordinate is x2, and the y-coordinate is y2. And we know that given any 2 points, that there's one straight line that goes through both points. So let's look over here what I have. I've rewritten the equation of a straight line as y equals a1x plus a0. And I just couldn't write the subscript there as when I typed it out. Suppose we specify the line, we want to find the line, we want to find the values of a1 and a0 that go with the line that passes through. So we want to find a1 and a0, the line that passes through these 2 points, the point 1, 4 and the point 4, 5. So what I do is I now substitute into the equation x equal 1 and y equal 2. So y equals 2 equals a1 times x, but x is 1 plus a0. So this is the first point substituted into the equation, gives me this. The second point substituted into the equation, where y is 5 and x is 4, gives me this right here. 5 equals a1 times 4 plus a0. So I have 2 equations here and here, and I have 2 unknowns, a1 and a0, that appear in both equations. Now to solve 2 equations with 2 unknowns, I can do it a number of ways. The way I decide to do it is I'm going to take this first equation and I'm going to subtract it from the second equation. So right here, I rewrite that first equation. Okay, the first equation I rewrite 2 equals a1 times 1 plus a0, right? That's the first equation. I subtract it. Okay, a0 from a0 is 0. 1 times a1, subtract that from 4 times a1, gives me 3 times a1. So that's what I have right here, 3 times a1. And 2 from 5 gives me 3. So when I subtract this equation from that equation, I get 3 equals 3 times a1 plus 0. 3 equals 3 times a1. That means that a1 equals 1. So we found a1. Now I'm going to take this value for a1 and go back and plug it into this equation right here. So I have 2 equal to a1 plus a0, and I substitute in 1 for a1. So I have 2 equals 1 plus a0. Okay, that tells me that a0 is equal to 1. So this solves a0 equal to 1, and up here we have a1 equal to 1. Now let's check to see if these 2 values, a1 and a0, solve these 2 equations. So I check. I write the first equation. 2 is equal to a1 times 1, which is 1 times 1, plus a0, which is 1. So that works. 2 equal 2. The second equation is 5 equals a1 times 4. That's 1 times 4, plus a0, and that works. So these 2 values, a1 equal to 1 and a0 equal to 1, solve these two equations. So that means the equation for the straight line must be this equation right in here, y equals x plus 1. So that's how we can take 2 points and use the 2 points to solve for the equation of the straight line that goes through those 2 points. Okay, now I'm going to do some more examples, and then I'm going to do some examples of higher order polynomials and how we can find the equations of higher order polynomials that go through data points. So until next time.